Well, hello there. So on this episode of Reloaded, this will be the initial episode. It was uploaded way back in 2013 originally. But what we did was we took a laptop motherboard, and it wasn't confirmed whether it was a dead board or a working board. It could have been working board for all I know, for all I remember anyway. The tutorial, it's a tutorial, but it's not a troubleshooting and repair video. Literally, all it does is it teaches you the ins and outs of SMT technology, that's surface mount technology, how to identify and read the coding for the resistors on that SMTs, how to remove and replace. Basically a tutorial to show you how to identify different SMT components and what you need to do in order to prep the board to replace things like that. So it's really an SMT identity tutorial, I suppose. So it's really not a troubleshoot and repair video. So back before you guys comment, well, we wish we could have seen this board working and everything. Well, it wasn't about that. But anyways, grab you a nice hot cup of coffee, sit back, relax, and enjoy the video. Today what we're going to do is, this is a laptop motherboard, and we're going to talk a little bit about surface mount technology. Now first of all, the surface mount technology is the small components you see here like this, and what we're going to look at today is resistors. And if you focus in on this resistor here, you can see letters on it, okay, and you should see 151. So we know that it's a 3-digit number. Now the first number and the second number is the digits 15, which means 15. The one after it is the multiplier, or how many zeros follow. So if it's 151, it's a 150 ohm resistor. If it was 153, it would be a 15 with 3 zeros, or a 15K resistor, 15 kilo ohm resistor. Sometimes you will see on these digits, you will see, if we focus in on this, it's a different card. If we focus in on this component, this resistor here, sometimes you will see components like that, or resistors like that with a single zero. Sometimes it will be 000 like this, like these ones on here. You will see that it is 000. Now what that means is 0 ohms, or to show you better, we got a power supply from a CRT monitor. It's the same thing as the jumpers here. All it is a jumper. So if it's a single zero or a 000, just all zeros, it's nothing more than a jumper. That's all it is. So there's no resistance at all. Now we're going to do some do's and don'ts in soldering techniques. And what we're going to do right now is show you how to replace one of these resistors. Okay, now first of all, you want to get your tip 10 just barely, and what we're going to do is we're going to remove one of these resistors. Let's single this guy out because he is right there by himself. Oh, another thing about these resistors too is if you've got a resistor with an R, if you had a 5R9, that is a 5.9 ohm resistor. Okay. Now, if you had like a point or an R47, well, that would be a 0.47 ohm resistor. Okay. So sometimes you'll see codes like that on the surface mount ones. Also, sometimes you will see other letters, and I got a list here, the composed list. So if you have a B, it'll be 0.1%, a C is 0.25%, a D is 0.5%, F is 1%, G would be 2%, J is 5%, K is 10%, M is 20%, and Z is 80%. Now we look right here, zoom in on this guy right there, you will see that it has a C in it. Can you see it good?
There it goes.
Okay, you will see the C, so that would mean, and let's see the value on that guy, it is what? 75C. So it's a 75 ohm resistor with a 0.25% tolerance, and that's what that means. Now, go ahead and remove one of these 150 ohm resistors right here. Let's take the bottom one, it'll be easier to get to. Let's pretend like he's a bad guy. So what we're going to do is we're going to remove it, and the best way to remove these is with the braid. You just kind of go on the side. You don't want to stay on there too long, because you can, I mean, this guy's bad for pretend, so you don't want to stay too long because you can damage the component. Then what we want to do is get some tweezers and remove him, and we'll remove him out the way. And see, he's very hard. Let's see how tiny he is right here. See, there he is right there. Now, if you want to see that it is 151, so we know it's 150 ohms. So let's put the fluke on it, and we'll get a measurement on it to make sure it's 150 ohms. Now, it's going to be very hard to do, but if you look at the fluke, you'll see it's pretty close to 150 ohms. So it is a good resistor, but we removed it to show you how to to replace it. Now here he is right here. Don't sneeze or you'll lose him, okay? So I'll stick that there so I know right where it's at. And then what I'll do, this is how you do surface mount resistors is, first of all, get some fresh braid and clean the pad. Okay, now what we're going to do is we're going to flow the pad. You want to do it this way as opposed to putting it on later. Okay, and you want very little solder on it. And this one's, there we go. Then we get the component again, and he is right here. Now this is the hard part, because first of all, getting hold of it, and then we got to line it up and get it over the pads just like that. Now what we want to do is get it situated where we can do this real easy. This is the extremely difficult part right here, because first of all, you can't hardly see. Okay, and then finish him off, and there he is. Now you always want to clean the work area, and what we got is alcohol that we put as plant sprayer on. So we want to adjust it like that. And you always want to clean after you solder a component, because the flux is conductive. So you want to make sure that it's nice and clean. Okay. Then what you want to do is make sure that you have soldered it properly, and we do this with a meter. You want to get right at the edge of the circuit, and you'll see that he is on there along with him. Okay, now some other things that I have seen techs do accidentally is while they are soldering, they inadvertently will, let's say we were soldering on this capacitor right here or something, and let's say we accidentally have a glob. This is something you do not do, is have globs of solder like that when you're working on this stuff, because you don't want that to happen. That's what you don't want. You don't want too much solder. See, look at that. That's a mess. Sometimes you can even drop solder, and inadvertently you'll drop solder and cause a bridge like that. Okay? That's something you don't do. But if you do happen to do that, you clean your iron, and what you do is you get you some flux. This is flux. And make sure that it is rosin core, that is rosin flux. And coat it with flux. This is if you have a bridge. Now we intentionally cause that bridge, but sometimes techs will get, I've had techs that's actually inadvertently caused a bridge. And all you do is you just clean it off like that. And there you go. Now, another thing, and of course you want to clean your mess. You want to clean it off. Another thing is on these capacitors, just like we got surface mount capacitors that are electrolytic. Sometimes you will have, the through-hole capacitors that are electrolytic. Sometimes you will have surface mount ones that are electrolytic. And I don't see any examples on this board of any that are electrolytic. But if you did, it would have a black mark on one end. And just like, let's pull out a capacitor here. Just like these capacitors, it has a black mark. The difference is, on surface mount, if it's a black mark on the edge, it's actually the positive side, not the negative. So you want to make sure that you know the difference if you're working on surface mount technology. Now some of you guys will probably never touch any surface mount stuff because that's for high-tech repairs. And some of that stuff, it's hard to get parts for. I have found the best for components. Now we want to talk a little bit about transistors. You do have surface mount transistors like this little guy here, and they are hard to replace as well, but it's basically, they all are the same as far as replacing. One thing that we do want to talk about is the transistor, and we have, for instance, we have several different ones here. We do use Radio Shack in emergencies. If we need something and we need it now, we'll go to Radio Shack. If they have it, we'll get it. Otherwise, I prefer to use my regular suppliers. One thing I like about Newark is they told me if they do not have what I need in stock, they would find it. So we have different varying types of transistors here, and what you got to pay attention with transistors is there's three legs on them. One is the emitter, one's the base, one's collector. And what you got to pay attention is the number on the component itself. Now this one has several different types in it. We're going to look at the 2N4401, and actually I think I got a bad one right here on the bench, and it is a 2N4401. I don't know if you can see. It's 2N. You'll see the number on the component itself, and there you can see it. Now what you pay attention to is the values, and for the 2N4401, we see it's got a voltage rating, maximum rating of 40 volts, 600 milliamps, 625 milliwatts power dissipation. That's power loss. Now we can see that all of the voltage and the currents and the voltage and the power dissipation is the same for the 3904. So that actually means if you don't have a 4401 in your, but you have a 3904, you can use one or the other. You always want to try to use what's available, though, that came with the board, but you can replace it with 3904 if you have to. Back in the lab, we're going to check out another monitor situation. This here is a site you do not want to see. What we got is a busted LCD screen. And what we're going to do is fix that. with a donor LCD screen. Now what we're not just going to simply replace them. What we're going to actually do is remove the skin from the LCD and replace it with this one, because this one the lamps are no good. This one the lamp's good, but the LCD isn't. So we're going to show how to remove the thin layer of the LCD itself, not just the screen, and we're going to replace it. These videos, you know how to take these apart, so we're not going to film that. So, okay, we're going to get started. Okay, so I've already got all the screws removed, and everything is ready to come right apart. We're just going to unplug everything, remove the cables. I already know that everything's fine here because it powered up. So first thing we're going to do is we're going to go ahead and get this apart, and we're going to remove the skin, the LCD skin. There's 3 little screws that we got to remove. Now when that's done, we unhook the wires from these little brackets here. Remove the plate. And that comes right off. And now the board powering the screen just kind of flops like that. You gotta be careful of these little cables here on the new one. This one we ain't gonna worry about because it's busted anyways. Now you got these little tabs on each side that we kind of pry up. We're gonna remove this whole metal trim, just like that, on all sides. And it pops right off. Now, all we got left is removing the LCD skin, and it should just come right out. You can see where it's busted. It's broke right here. Right there. If you hold it up to the light, you can see. Real good where it's leaky, where it's busted. Now all we got to do is do the same process, exact same process with the donor. Same thing to remove the skin from it. Okay. Now we're going to take our donor and we're going to do the same thing. We're going to remove this skin here. So that's what we're going to do. We're just going to kind of swap them out. To take this one apart is the same process as taking this one apart. They're all basically, even though some of them may be just a little bit different, they're all basically the same. Okay, now we've got the donor LCD panel removed. If we hold it up to the light, we can see that there are no scratches, no cracks, it's not busted, and it would appear to be good to go. So what we're going to do is we're going to go ahead and reverse the process and put everything back together. We got a power supply here. It was tested good. My tech was 316, that is Big Jesus. All of my techs have a number. Mine is 214. So if you see any parts from us with 214 on it, then you'll know it's good because it's mine. Okay. So now what we're going to do is Big Jesus tested this. We're going to show you. This is a simple LED tester, LED indicators. This actually would be really easy to make, and maybe one of these days one of our videos will show you how to make one. Okay, we did not make this, by the way, but they would be easy to make. What we're going to do is show you how to test it with that, and we'll make sure it's good, because now let's go plug it in, and we'll make sure the power is on, and then we're going to plug it into the tester here. We see that all the rails are active. Okay, we can plug in the 4-pin,
12 volt.
And we'll see that we got 12 volt reading there. Plug in the hard drive.
5 and 3 volt.
5 and 12 volt.
Okay, I'm sorry.
Now.
Alright.
Okay, so this has been out in the shed, and because it is so cold out there, the circuit board is extremely cold. Now, when you got dealing with cold boards like that, you're not able to do any soldering work on them. It just won't happen. So what we're going to do is warm the board up a little bit. You don't want to get it too hot. And we got a heat gun we're going to use on it. And we're just going to heat it up a little bit.
Much more than a hair dryer.
Don't want it too hot. We don't. Just going to heat up the area we're working in. Just raising the temperature of the board a little bit. Okay. Now it should respond better.
Ooh, that thing is hot.
Get the soldering off. That's better. Oh yeah, that's much better. There you go. Okay, what we got here is a little tip, trick, both, whatever you want to call it. If you look at this power supply, we can see that we do have bad capacitors. Down here, you can see that one's bulging. That one is bad. What's happening here is when we plug it in, and we got it plugged into this IBM. This is our lab rat right here. When we plug it in, and we turn it on, it's turned on. There's no power to it at all. So what we're going to do is show you a little trick. Now let's pretend, sometimes caps, transistors can be bad and you can't tell. Like, we know these are bad because we can see them. But sometimes caps can be bad and you can't see that they're bad. So rather than diagnose the whole board, we want to kind of pick an area. You divide it into quadrants. We already know that this side is bad. And we already know that it's bad here because we can see it. But let's pretend like we couldn't see that. So we would divide it into quadrants, and we would heat up with okay, I got a heat gun, but a hairdryer works just as good. You can use a hairdryer for this trick. And what we're going to do is we're going to heat these caps up, and we're going to show you that just by heating them up, it will power on the computer. Okay, so what we're going to do is we're going to go ahead and start heating it up. Usually you want to heat it up till it's hot to touch. Okay, we're going to heat it up. While we're heating it up now, we're going to start pushing the power button. I'm going to keep heating it up. Just get it a little bit higher gear here. And there we go. And now this will stay powered up until these cool off. If you touch it, it's really hot. So these are good ones, of course, but this is where we were shooting with the gun. This is a bad one right here, and it's really hot. But it's going to be like that until it cools down, and once it cools down, the system will shut off. So basically, we know now by heating it up that it's in this quadrant right here is where the problem is. So from there, we would be troubleshooting these components in this quadrant, and that keeps us from having to go over every component or trace the circuit from the very beginning. And it's going to keep powering up until these cool off. Once these cool off, the power supply is going to shut down. And so now if we wanted to fix this, all we had to do is replace those caps and we wouldn't have the problem of the shutdown. So that is a neat tech tip that you can use for troubleshooting. And that's going to be it for this episode of Teslatronixlab. So next time we will have some other neat stuff for you. See ya.